Up next, over the past few years, a team at the University of Nebraska Lincoln has been working on a new piece of technology that's geared toward making field maintenance much easier. Their solution is the innovation that they're calling the FlexRow. This unmanned ground vehicle can distribute seeds, chemicals, and fertilizers. For more on this story, we return to Market Journal's Mike Straub.
UNL plant scientists and biological systems engineers have been working together to build what is known as FlexRow, short for Flexible Robot. The autonomous multi-purpose platform hit the field for the first time this summer for demonstration at Roger Memorial Farm.
We have a multi-purpose robotic platform called FlexRow, and like I said, it's multi-purpose, so we could do planting, we could do phenotyping, and also spraying. So at Rogers Memorial Farm, we kind of demonstrated how our planter row units work.
FlexRow is an important robotic tool that can perform targeted operations while saving cost and implementing climate-smart agriculture. Spraying and fertilizer application are currently being tested.
We are going towards climate-smart agriculture, which is really important, and robotic tools and technology tools have a big role to play. So we see FlexRow as one of those important robotic tools that can do very precise operations in the field while saving costs. If you think about targeted spraying, so only spray where things are needed instead of spraying throughout the field. Fertilizer application is another one we're exploring, where can we do very targeted fertilizer application.
The FlexRow is intended for multi-purposes and is built to be modular. It can collect data through onboard sensors used to measure such things as reflectance, plant height, temperature, and humidity.
This machine has been in development since 5 years. So a couple of master's graduate students worked on it. Now we have a third graduate student working on it. And when we started, our goal was how can we develop a field usable robotic platform that is modular, but also it should have the ability to do multiple operations. So we have 6 computers on this machine that exchange information, or a network called CAN bus, so that we can do very precise operations. And also we're using different camera technologies to look at green pixel fraction, which is basically in an image how much greenness is there. We're using spectrometers that tells us nutrient deficiencies. So there's a lot of sensor technologies that we're using, and using all that information to make decisions so that we can very precisely do site-specific management.
While someday the FlexRow could be a part of everyday use for farmers and producers, developing farmer-friendly robotic solutions that are easy to use involves a lot of obstacles.
This is a research prototype, so taking this to an actual product that farmers can actually use is a big hurdle, So how do you make a product out of a prototype, right? So that's very important, So exploring if some of my students, they want to do this as a startup company, that is one way to do it, take the intellectual property we developed and make it into a company. So that's one avenue. I think the important point is how can we develop farmer-friendly robotic solutions is what is important. How can we give a system to a farmer that is not too complex, and it is easy to use. So there's a lot of thought that needs to go into it.
Modular technological tools are important when focusing on climate-smart agricultural practices. The end goal of a product like this is applying less in the field while producing more.
For climate-smart agriculture practices, it is very important to have modular technology tools, and especially robotics, automation, artificial intelligence. All of these need to be combined, brought together in a very synergistic way, so that we can actually create very functional systems that will help us with the goal of how do we apply less in the field but produce more, without affecting the environment in a negative way.
FlexRoll could be a product which, in the future, could aid researchers with a few acres of plots to farmers with thousands of acres. Before this can happen, however, there are some hurdles to overcome. More real field testing needs to be done before the next steps can be taken. Reporting for Market Journal, I'm Mike Straub.